Hello, all automation lovers. I'm trying to share my skills and the most practical use of Siemens PLC programming. So please subscribe and share my videos. On today's video, I'm going to create a function block that is used for controlling many Danfoss VLT drives, networked by Profibus or by Profinet. Okay, let's go to the PowerPoint. So it looks like this one. This is a block diagram. Here is the Siemens 300 CPU and here are three time possibilities. Okay, let's see some important terms or okay. The first one is the control word. This control word is to send data from Siemens PLC to the Danfoss PLT. So it's a one word and it's 16 bits. So each bit has its own meaning. This side is for 0 and this side is for 1. Okay, for example, if bit 0 is 0, it means reference value on the local, and if it is 1, it means external selection or of external selection of the least significant bit. And if bit 1 is 0, it means reference value. If it is 1, external selection, most significant bit. Likewise, if bit 6 is 0, it means ramp stop. If it is 1, it means start. So I have already made a video on this, so you can watch there. Okay, let's see this one. So this is the telegram for the Danfoss VLT. So all 16 bits are here. So if you want to stop the motor or a drive, you have to send 43F. If you want to run, you have to send 47F. If you want to run reverse, you have to send 847F. If you want to reset or acknowledge, you have to send 4FE. So we will use this later. And the other important thing is the status word. The status word is used to get data from the VLT drive to the Siemens 300 PLC. Okay, it is also it's one word and it is 16 bits. So each bit has its own meaning. Okay, if bit 0 is 0, it means controller not ready. If it is 1, controller ready. Okay, likewise, all have their own meaning. So we have to use those bits later on our function block. So let's go to Simatic manager and start creating. Okay, before going to the programming, let's see the hardware configuration, what it looks like. Okay, the hardware looks like this one. Here is the Siemens 317 2DP PLC, and here are two Danfosses, as you see. So if you have more drives or more motors, you can add more Danfosses or here. So this one. So you can drag and drop here and add as you want. Okay, but I don't want. I only have two. So this one is node address 10 and this one is node address 12, or you can check here. And the telegram is PPO6. This one, PPO type 6 word constant. So its input address starts from 100 and the output also starts 100. This must be equal. And for the other one, the node address is 12 and it's also PPO type 6 and start address is 200 and for input and for output also it starts from 200. Okay, let's close end. Okay, so to save time I have already created the function block, so I only discuss each thing here. Okay, before creating the program, let's see the local variables. So for here, the local variable for this function block is, as you see, for the input I have added an address, that's the address of the drive or the DLT, and the target speed or the reference speed that I have to send to run is an integer, and the other is drive enable or run ramp select to select ramp here, ramp 1 or ramp 2, quick stop, run, reverse, reset, and clock pulse 1 hertz. Okay. On the output side, I have added some local variables too. Ready or no error, local operation mode, DC voltage, okay. No thermal warning, actual value. This is the feedback or the actual running speed of the drive, and no save stop. So I have added those on my output. Okay. On the temporary, this is the main thing that has a little bit different. One thing we have to know is that to send some commands and some data to the drive, and also receiving some data from the drive. So I create one variable to send, that is control word, and to read I said status, one variable. Okay, here it is struct means it has many data types. Maybe it has boolean or integer or real. Okay, let's see the control first. Double click, so it opens here. So the control has two things here also, the control word and the set point or the reference speed. So the reference speed is word, if we can leave it, but on the control word it is also struct here. So that means it has some other variables or data types. So let's open again this one. Okay, it opened. So all control bits are given name here. So as we see on the PowerPoint, these things are put on the local variable here. So bit 0 is the set point the least significant, bit 1 is set point most significant, bit 2 is break ramp, bit 3 no casting, 4 kick stop, 5 use ramp, bit 6 start, and bit 7 reset, and bit 8 jog. Likewise, all 16 bits are defined here. That's it. So we will use this one later on programming. So let's go to on the status. We see on the control. So let's see the status. It had also two things here. The status is status word and the actual value or the actual running speed of the drive that read from the drive. So this is an integer, so we leave this one, but the status word is still struct, so it has other data types under it. So let's open again, double click. So all status word bits are listed here as a local variable. This one. Okay. So bit 0 is for the controller ready, bit 1 is drive ready, bit 2 costing, and likewise all status terms are written here as a local variable. Okay, great. So if you are following me, let's show one time again. On the input side, I put those local variables. On the output side, I put those variables, and on the temporary, I created three variables here. The first one is the control, but under control, I have put some variables. Okay, on the status also has two variables, but under status word, I have listed all the status. Thank you. So it looks like this one, the local variable creation. So let's now see. Okay, network one is reading of the IO address or calculation of the IO address of the drive. So I get address from the input, as I said, then change to a pointer format address. Okay, this one address, then it put to in the here temporary as a pointer format. So I will use this pointer for later. Okay, on network 2, I will read the status or the parameter of the drive. So to read, I read the PI double pointer address here. So the address of the drive and getting that data and putting to the local double memory 4. This one. Sorry. Okay. This one, address 4. Okay, so I read the drive and put on local data for memory bit data for. Okay, then I will extract each bit now here. So if bit 9 is not active, that means local operation. If it is active, it means sorry. If bit 9 is not active, that means local operation. If it is active, it means bus operation or by field bus control. Okay, if bit 13 is not active, it means DC voltage okay. If it is active, that means DC voltage not okay. Okay. If bit 15 is not active, it means no thermal warning. If it is active, it means thermal warning. So I am extracting each bit of the status word to its bits and its. So if bit network 6, if bit 40 is active, that means no safe stop. If it is not active, it means safe stop. That's terminal 37. If terminal 37 is active, get power. On network 7, drive no fault or drive ready. So if control bit 0 and control bit 1 are active, that means ready or no error. Or if bit 6 and bit 3 are not active, it also means drive ready or no error. Okay. Network 8 is we have done on the status word or reading, so we have to start sending or writing data to drive. So to send, we read the actual value or the sorry we are reading the actual value of the drive speed. So we read from status here and we change integer to double, then double to read, then divide by 16.384. Because the drive speed is written on from 0 to 4000 in hexa. So we have to change this to a human readable value. That's 0 to 1000 decimal. So that's why we divide this one. So we get the actual value by decimal here. On network 9, we have to send the target speed to the drive. So with the target speed we given is from 0 to 1000 in hexa, or this will scale from 0 to 100 hertz. So to do that, first we have to change from integer to double, then double to read and multiply by 16 3.84. So and put to the set point or control to the set point. So we write the control the set point or the reference speed on this variable. Okay. Okay, network 10 is to set and clear the variables. As we see on the control word on here, some variables are never changing on those four options. Like bit 0 is always 1, and bit 1 also always 1. Likewise, there are bits like bit 11 always 0, bit 12 always 0. So we have to set and clear these values. So those value always 0 will be clear, then set to 0. So bit 8, bit 11, 12, 30 and 40 are always 0, and the bits that never change always 1 will be set to 1, and those are bit 0, bit 1, bit 2, bit 3, bit 5, bit 10. So we do this, that bit never changes. So we will play with the other bit changing. Okay, example. Forward run. To run forward, bit 6 must be active. So this will be input from the input also from the function. So as you see, I on the input I create variable drive enable and reverse. If both one of the bits are active, bit 6 will be active. So if drive enable is active, the drive will run forward. Okay, P12 is for fast. So network 12 is fast stop. So on this, uh, 8 bit 4 is for the kick stop. So if the kick stop is 0, it means kick stop. If it is 1, it will stop the drive. If kick stop is at 1, it will stop. So for reverse running bit 50, so if the input reverse is active, bit 50 will active and the motor will be run reverse. Also this bit 6 must be also active to run reverse. That's why I added this one here. Okay. So bit 9 is to select the ramp. Is that ramp 1 or ramp 2? If this one is 0, it means bit 1. If it is 1, it means bit ramp 2. And here, to reset, bit 7 must be active. So if the input reset is active, then this will reset the drive. This is a clock pulse. Okay, after we done all necessary parameters we have to write or send to the drive. So we store our data on this variable, the set point in the control word. So we have to send these variables to the drive. So local double of memory area 0, that means this one, and send to the pqd and the pointer address. So it will send to the drive. Okay, thank you. I have created the function block here. Okay, so I've created the function block, so we will use this later on part 2. Okay, if you let's show overview of the program. Network 1 looks like this one. Network 2 looks like this one. Network 3 looks like this one. Network 4 is like this. And network 5 looks like this one. 6 is like this. 7. I'm showing this for you to, if you are following me, to write correctly. I'm just showing. If network 8 is for calculating speed of the Danfoss. Network 9 is the calculating of the target or the reference field to send to the drive. Network 10 is to clear and set some bits that never change. And network 11 is to run drive forward. Network 12 is for pick stop. And network 30 is for reverse run. Bit 50 and the bit 6 must be active. That's why I added here. Okay, bit 40 is to select the ramp. Is that ramp 1 or ramp 2? And network 50 is for reset. So to reset the Danfoss of the, if it has problems or faults. Network 60 is to write the control word. Okay, thank you. I have done this creating the function block. Also on part 2, I will show you how to we use that one. Until then, have a nice time. Okay, okay. Thank you.